Now today we are going to go over what cocktail sort is. And cocktail sort is a variation of bubble sort. So if you don't know how bubble sort works, definitely check out the previous video. Bubble sort iterates through the array, comparing adjacent elements and swapping if necessary. And the only difference between cocktail sort and bubble sort is that cocktail sort alternates directions. It goes up and down, whereas if you have bubble sort, you go only this way, right? Instead of only going left to right. So let's say, for example, if we were to look at bubble sort, as we iterate through our array and sort elements, we know that we have two parts to our array, unsorted and sorted here. As we loop through, the sorted portion at the end is going to get bigger and unsorted portion is going to get smaller, right? That's what bubble sort is. But what cocktail sort does is it goes to the right and then it comes back to the left. So that means that we're going to have our sorted portion here, and then we are going to have unsorted portion here. And this is going to continue until we sort everything. So you might ask, why is cocktail sort better than bubble sort? Well, the reason is because the cocktail sort solves a problem that's named the turtles problem. Let's say that we have an array with a bunch of numbers, and if you were to use bubble sort, our largest number is going to end up at the end, which is going to be sorted, and we iterate the array sorting all the largest elements first. But when we have a small number towards the end of the array, that means that this small number is going to take really long to get to where it is supposed to be. So over here, for each iteration, -3 is going to move here. As 3, it goes to the right place, and then it's going to go here as 2 goes to the right place, go here, so on and so forth. So that would take n squared time complexity, right? It's going to be sorted after all the elements are sorted. So bubble sort is good at handling large elements because what it does is it just goes to all the way at the back and sorts it. But smaller ones, it's gonna take a while because it's gonna move once at a time per iteration. So to solve this problem, we implement cocktail sort. So cocktail sort is going to sort 3 first to the correct place, and then it's going to go right to left. So it's going to sort -3 to the correct place, and we do that for all the elements. So you can see that right away we might be able to save few operations because we don't have to move this one by one each time, whereas bubble sort you have to do that. So bubble sort has no problem sorting large elements that are in the beginning of the list, so that's our 3 here, but it is slow to handle small elements that are at the end of the list, so that's our -3. It sorts large elements first as it sorts left to the right, pushing large elements to the right, and as a result it's slow to handle small elements at the end because it's moving close to the beginning of the array once for each iteration. So this -3 moves once after 3 is sorted. After 2 is sorted, it moved once again. When 1 is sorted, it moves once, so on and so forth. So that's really slow, and that's what cocktail tries to solve. It tries to solve the problem by iterating back and forth between the unsorted array. And if you remember again, we have kind of 3 portion to our cocktail sort: sorted portion on the right, sorted portion on the left, and unsorted portion in the middle of the two. Now let's go over our time complexity really briefly, and this is actually exactly the same as bubble sort. And you might ask, if it's exactly the same as bubble sort, why is cocktail sort better? And we will answer that later. So best case is going to be O of n when everything is sorted, same as bubble sort. And worst is going to be O of n squared when everything is in reverse order. Although cocktail sort has the same time complexity as bubble sort, cocktail sort performs less than 2 times better. So less than 2 times better, something in between here. So it might be 1.9, we don't know. It depends on the input. And that's illustrated over here. Why might cocktail sort be better? As you can see, we have our input array, and our smallest number happen to be at the end of the array. And if you were to use bubble sort, it will require 4 passes. This is our, again, original input array. So our 5 is the biggest number. So our 5 is sorted now. 4 is second biggest. 4 is sorted. 3 is sorted. 2 is sorted. 1 is finally in the correct place. So it required 1, 2, 3, and 4 passes. And you were sorting our largest elements first, and the second largest, third, fourth, and so on. But if you were to look at cocktail sort, and cocktail sort left to right and right to left is a one pass. It's a one operation. So what it does is it's going to first sort the largest element, which we did for 5, and then it's going to sort the smallest element, which is going to be 1. So we sorted all the way here, and guess what? Our array is already sorted. So 4 versus 1 pass. So because of this turtles problem, we can say that cocktail sort performs better than bubble sort. Now lastly, if we were to look at our space complexity, it's going to be O of 1, and we just need an auxiliary space for our variables because we are using the in-place method for cocktail sort, just like bubble sort. If you guys find this helpful, make sure you guys like and subscribe. Thanks. Now let's go over our solution for cocktail sort. And for cocktail sort, we are just going to code one solution that's going to be really optimized. And the reason is because I found no incentive to really go over other unoptimal solutions because we did that whole thing in bubble sort. And again, cocktail sort is going to look really similar to bubble sort. So I thought we just do one final solution and just call it a day. Now this is our pseudocode, and give it a go if you like. You probably notice that as you read through, it's really similar to, again, bubble sort. So first thing we do is create a function that takes in an array, which is our input array, create a swap function, create a variable to check if it's swapped or not. Next, create a variable to check the current iteration, and we're going to set that to -1. We're going to create a do while loop, and this is going to run as long as swapped is true, and we're going to set swap variable to false, increment iteration by 1, and up to here it's exactly same as bubble sort. Now we're going to create another for loop, and we want to iterate starting at index is current iteration, and I'll explain that why later. And we're going to iterate until index is less than or equal to length -2 minus I. We do this because we want to avoid comparing elements in the beginning of the array, because remember, unlike bubble sort, we are going to have sorted elements towards the right and towards the left, and the middle elements are going to be the elements that are not sorted. So if the adjacent element is smaller than the current one, we swap our elements, set swap to true, and we do that for all the operation. And this iteration over here is doing left to right operation, and that's our bubble sort. Now after we're done with that, we check is swapped equal to false. Well, if it's equal to false, that means that it's already sorted. So we just break up from the loop. Now we set swap to false again, and we iterate this time right to left. So this was left to right. This iteration is right to left. And we start at index length -2 minus I, and it's the same reason. We want to avoid comparing and sorting already sorted elements. And we do that until j is greater than or equal to I. And that's for the beginning of the array because we don't want to, again, compare and sort them. Next, we check if the adjacent element is greater than the current one. If it is, we swap, set swap to true, and we do that for all the elements going right to left. And finally, when we're done with the whole thing, we return our array. So that's it for our pseudocode. Again, it's really similar to our bubble sort. Definitely do give it a try. If not, just come back later. Okay, now let's start coding our solution. I have my swap function, and I just coded there because we made so many swap functions. First thing I'm going to do is I'm going to make a variable named swapped, just declare it, and our I to check the current iteration and set that equal to -1. We're going to make a do while loop, and as long as swapped is equal to true, we are going to run this. Finally, we are going to later return our array. First thing I'm going to do is I'm going to make swapped to false and increment I by 1. So each time this loop runs, we're gonna set swap to false and increase I by 1. Now it's time to make our loop going left to right. So this is pretty much our bubble sort. So let j is equal to, we want to start at index I, and as long as j is less than or equal to array.length -2 minus I, and we're going to increment by 1 each time. And I'll explain this whole thing why it's like that again later. Next, we need to check. So if my adjacent element, so that's going to be array at element j plus 1, if this is less than my current element, what I want to do is I want to swap. That looks good. And finally, we set swap to true. Okay, that's our left to right operation. So let me just write it here. So this is our bubble sort pretty much. Now we need to check. So if swapped is false, what we're going to do is we're going to break. So if swapped is false, that means that array is already sorted. So if no swap already sorted, break. So break out from the current loop. And now we need to handle right to left operation. And that's pretty much what cocktail sort differs from bubble sort, right? So for this one, we're going to use a for loop. Let j is equal to array dot length minus 2 minus I. We're going to iterate until j is greater than or equal to I. This time we're going to obviously decrement by 1 because we're going right to left. And we check is adjacent element, which is represented by element at index j minus 1. If this is greater than our current element, what do you want to do? We want to swap, pass in our array, and pass in our two indexes, and finally set swap to true. Okay, so let's check our result. And as you can see, the first one looks good. Let's just uncomment this. So array with 100 random elements starting at -100. Everything seems fine. Yeah, everything is good. So that's it for our cocktail sort. But let's just uncomment this and go over our code one more time. Okay, major difference between bubble sort and cocktail sort is these two lines pretty much. And I think everything inside that for loop is pretty intuitive, so I won't really go over that, but let's just go over starting over here. Now, in the first iteration, I is going to be evaluated to 0, right? So we're going to start at -3 and sort our elements as we go through the whole thing. But we want to stop when the index is length minus 2 minus y. And why is that? And again, for the first iteration, I is going to be 0. Well, the reason is because when we iterate the whole thing, if it was a case that if we iterate the whole thing, there is no adjacent element. It's undefined, right? So j plus I is going to be undefined. So that's why we want to stop at array.length minus 2, which is this number. And our adjacent number is going to be this. And as we go through our first iteration, number 3 is going to end up all the way here, right? And we have one sorted number on the right. And we go to our right to left iteration. So we start at same index. So this is going to be over here because we don't need to check our already sorted element, and our adjacent element is going to be 1. So we do our comparison until j is greater than or equal to I, and as we go right to left, we are going to sort one element, and that's going to be -3. So after one pass, we have two elements that are sorted, which is -3 and 3 over here. So we're going to keep doing that, going back and forth between the middle of these sorted elements, and we sort one element to the right and one element to the left. And we do that until we sort everything and we get our final result. So that's it for cocktail sort. As you can see again, it's really similar to bubble sort. If this really confuses you, I really recommend you to go over how bubble sort work. If you don't, it's actually kind of hard to understand. Now let's go over our time complexity. I know that we went over our time complexity pretty much in detail, but let's just go over it one more time because it's good to solidify a few things. We want to really get how cocktail sort works. Now, all the time complexity, best, average, and worst is exactly same as our bubble sort, but it actually performs better. So although cocktail sort has same time complexity as bubble sort, cocktail sort performs less than 2 times faster than bubble sort. So for example, let's say that we have an input array of this, and you notice that we have a turtles problem where the smallest number happened to be towards the end of the array. And if you were to use bubble sort like here, it would require 4 passes, meaning each iteration, you're going to sort the largest number, second largest, third, fourth, and finally our array is going to be sorted. Well, that's slow, right? Because number 1 went from index 4 to 3 to 2, 1, and 0. That's a long time. And this is all n squared operation because you have to do the whole thing. And we are only able to move 1 by 1 to the left each time. But cocktail sort resolves that problem, and it only requires 1 pass. So at first, it's going to work exactly like bubble sort, where it sorts the largest number going left to right, but it's going to grab that smallest number and then sort it in the correct place at index 0 as it goes from right to left. So it just required 1 pass. And as you can see, 4 passes versus 1, which is better. I mean, cocktail sort is so much better. That's where cocktail sort shine, especially when we have a turtles problem and it just resolved that really quick. Now, as for space complexity, it's going to be O(n) because we use in place method for our solution, and it just requires auxiliary space for our temporary variables that we use. So that's it for our time and space complexity, and I hope this really helped you a lot. If you guys find this helpful, make sure you guys like and subscribe. Thanks.